math YouTube channel. Today I'm back with another example on solving an oblique triangle. So guys, in this case we have a triangle XYZ where the lengths for side X and Y are already provided and we have the measure of angle X. So guys, in order to figure out the rest of the three things that are missing here, which is one of the sides and the measure of two angles, the first thing we're going to do is we're going to actually draw a triangle for our reference. So I'm going to draw a triangle. Guys, you're free to draw the way you like, and I am going to draw like this, and I want to be consistent with what I did in my notes. I call this X, this Z, and this Y. Then let me label the given pieces of information. I have the measure of angle X, so this is my X, which is 39.7 degrees. Guys, once this information is provided, my first step is always to draw a triangle, and that makes it easier for us to actually solve for the missing pieces. Now I don't have the measure of angle Y, I don't have the measure of angle Z. Those are the two things that we have to figure out. And then what else is given? I have the measure of X, which is the side opposite to angle X, which means this side. So my X, lowercase x, is 23.5. And then what do I have? I have the measure of angle Y, which is the side opposite to this angle Y, right? And this is lowercase y is 9.8. And what we have to figure out is the lowercase length for x, y, or z, and then these two angles. So we have to figure out what is the value for length of z. Then we also have to figure out the two angles, which is measure of angle y and also the measure of angle z. So in order to do that, right now we are using the sine law. So we are going to set up the sine law, and from there we can figure out how we can find the missing pieces. So first let us start writing the sine law. So guys, there's two ways of writing the sine law. We are going to use one of the ways, and one of the ways is we start with the side length. So let us say we start with x. So if I start with x here, then what goes down here is this sine of the angle which is opposite to that side. So what is the angle that is opposite to side x? Obviously we can see that it's going to be that uppercase x. So it is x over sine x equals to lowercase y over sine of the angle y, which is going to be equal to the third side, the ratio of the third side, which is lowercase z over sine of angle z. So this is the sine law for this particular triangle, and now we are going to fill in the values that are provided, and then from there we can see what is missing. Okay, so here guys, let me fill in those values right here. X is already known, so it is 23.5 divided by, I have sine of x, which is also known, so sine of 39.7 degrees, and this is equal to y. We also know the length for y, it is 9.8 divided by sine of y. We don't know the measure of angle y, so it is sine of y, and the third one is going to be just the z. We don't know either the length z, or we don't know the value for the angle z, so that's the third one. So obviously we can see that we should first start by comparing or writing these two as an equation, and then from there we can find the value for y. Once we have the value for the measure of angle y, then we can go ahead and find the measure for angle z. So let us do step by step. Guys, let me first take these two ratios, and guys, keep in mind, first we write the sine law, which has three ratios, and then we work with two at a time. So here I'm going to work with these first two at a time. So from here, guys, I'm taking it up right here. So we have 23.5 over sine of 39.7 equals to 9.8 over sine of y. So in order to find the value for angle y, we have to cross multiply. So let us go ahead and do the cross multiplication. Once we cross multiply, we get 23.5 times sine of y equals to 9.8 times the sine of 39.7. Guys, I don't have to write a times here. It is understood that this is multiplied. Now in order to get sine y by itself, obviously we got to divide by 23.5 on the both sides. 23.5, so this crosses, I get sine of y equals to, and when we simplify this, what do I have? Okay, so I went to 4 places of decimal, guys. I have 0.2664, And looking at this, we know that the sine value can be between -1 and 1 because the range for a sine function is between -1 and 1. So this is a perfectly valid value for a sine function. In order to find the value for y, obviously guys, we cannot see that decimal on the unit circle. So we have to use a calculator. So using the calculator and using the inverse key on the sine inverse key on a calculator, this is what we get for y. So we get y close to 15.4 degrees. But guys, we already know that sine is not only positive in the first quadrant, and this is the angle in the first quadrant, it is also positive in the second quadrant. Guys, if you have watched my previous video, we know how to find that other angle in the second quadrant. It's pretty simple. All you have to do is to find that second angle whose sine is also going to be positive 0.2664. What we basically do is we take 180 and we subtract this given angle, and this is what we get, 164. Let me make sure that I'm not writing anything wrong. 164.6. So that means we have two values for y that whose sine is 0.2664. So at this point, we would say that there is going to be two cases. Guys, you have to watch my previous example to see that there is a possibility for two triangles, depending on what the value for sine is. I have already covered like 3 or 4 different examples. Guys, in one of the examples, we had sine of y something greater than 1. So in that case, we know that sine cannot exceed 1. So what do we conclude? We conclude that we cannot actually create a triangle. So there's no solution. We cannot really create a triangle in that situation. Then the other type or the other example that we looked at was where we had a sine of y something in between -1 and 1, and then we were able to get two values for y, and from there we had two cases. Same thing happened here. We have sine of y equals to something which is within the range of sine function. So we got two different values. So from here we may have two cases. But guys, we have to look carefully at both the cases and see if there are really going to be two cases, or maybe there's just one case. But at this point, guys, we cannot just have one angle. We got to have the other angle as well, because both these angles satisfy this equation. Okay, so make sure when you get this first angle from your calculator, which is also thought of as a reference angle, go ahead, do 180 minus that angle and find the other angle. Okay, so let us now divide this into two cases, case 1 and case 2. So guys, first let us start with case 1. In case 1, well, this is going to stay for both the cases, but what is different in case 1 here is, what is different between case 1 and case 2 is going to be the value for y. So measure of angle y is going to be 15.4 degrees. So based on that, and we're again referring it to the same triangle, guys, first thing we want to figure out once we have this is what is the measure of angle z, right? We have the measure of angle x, now we have the measure of angle y. And guys, keep in mind we're doing case by case. This is the first one and this is going to be our second one. So we can find the measure of angle z first. To find it, we know the sum of all the three angles of a triangle is 180. So it is going to be 180 minus the sum of the other two. What are the other two? 39.7 and 15.4. So I'm just going to write them, 39.7 plus 15.4. And when we simplify this, what do I have? Let me make sure. Okay, I have 124.9 degrees. That is good. So we have the value for measure of angle z. Once I have the measure for angle z, now I have to find the length of this side. So we can do that just by setting up. Again, I'm going back to the same sine law. And from here to find the value for z, I'm going to work with this ratio and this ratio. Guys, you can work with this and this. It is up to you. It does not really matter. Okay. So in my notes, I have worked with this one and this one, first one and the third one. They're all equal to each other. So you are free to use any two ratios. So let me go ahead and set it up the way I have here. So I wrote x over sine x equals to z over sine z. Guys, I always like to write the general forms first, and now I'm going to replace the values for x and sine x and z and sine z. So I have x is 23.5 divided by sine of 39.7 equals to z is the missing value here, the missing parameter, and divided by the sine of z. Now we have the value for the angle z, which is 124.9. Obviously, guys, at this step, you know, we have to cross multiply, and I think I can skip that step. I still have to get rid of some of the things here so that we can finish doing this. So I can get rid of this information. Okay, guys, now from here, when we cross multiply, so I'm taking it up right here. So when we cross multiply, we get z times sine of 39.7 equals to 23. Guys, I'm just cross multiplying and times sine of 124.9. So to get z by itself, we have to divide both sides by sine of 39.7, left hand side as well as on the right hand side. So guys, this crosses out, we get z equals to, so we got to use the calculator to simplify this. I have already simplified this and I get z close to 30.2. I went up to 2 places, so you should go up to 2 places only here. Sorry, I went only to 1 place, I'm sorry. So that is my z. So I got everything in case 1. I already had my value for x, I had my value for y, I found the value for z. So I have all the 3 angles, and then I needed 3 sides. Guys, I already know the values for 2 sides, and then I just had to find the value for the 3rd side. So we have solved it completely for case 1. Now let us look at the other case, which is case number 2. So in order to look at the case 2, guys, I have to get rid of some of the information. Maybe I can get rid of this stuff right here. Guys, I don't have enough room here, so I have to get rid of some stuff. I cannot leave everything here. So let us look at the case number 2 and see if there is a possibility for case 2. So the very first thing we're going to do here is case 2. I'm going to start by writing the measure of angle y for case 2 is going to be 164.6. Now wait a minute. Again, for case 2, we already have the value for x. We now have a value for y, and the first thing we have to do is find the value for z. In order to find the value for z, what we have to do is we have to we know the sum of the triangles is 180, so 180 minus the sum of the other 2. But here's the thing, guys. If you look at this number and the value for angle z, angle x, so let us do something here. Let us 164.6. Let us add these two angles. Sorry, y and x, because this is the y value for y. Let us add these 2 angles and see what we get. So if we add these 2 angles, and let me use a calculator for that. So I have 164.6 plus 39.7. Okay, so guys, I'm getting 204.3. So is that even possible? We know that the sum of the angles of a triangle, sum of all the 3 angles of a triangle is supposed to be 180. Here we are adding 2 of them and we're getting something which is way bigger than 180. What does that mean? That means there is no solution, or there's no possibility of a triangle when one of the angles is 164.6 for this particular triangle, because if I already add this other angle, I'm exceeding 180 degrees. So there's no way we can find the value for angle z, because the other 2 are already adding up more than 180 degrees. So what does that mean? Guys, in this case, it means that here, of course, we were able to get 2 values for measure of angle y, and then from using the first one, we were able, and it made sense, because once we find the measure of angle z, we got a value for it, and sum of all the 3 angles adds up to 180, and then from there we were able to find the missing side. But guys, with the other value, which seemed at that point seemed to be a valid value, but then we realized that, hey, this cannot be a value for the angle y here. Why? Because these 2 angles already add up to something more than 180 degrees, which is not possible in any triangle. Okay, so there's no solution for this case, so you don't have to do any extra work on that. In this case, there's only one triangle which is possible, which has these values for x, y, and z is already given, and we found the value for the missing side z and the measure of angle z. Okay, so this is I think this is the last type I wanted to talk about in this section on using the sine law for solving triangles. Guys, in the next video I want to show you how to find the area of a triangle, and then we're going to go into the